Okay, let's work on taking the derivative of this big old fraction. So this fraction looks intimidating at first, and you may be thinking, I need to use the quotient rule to do this. But we don't really in this case because we're dividing by a monomial. As we're dividing by this monomial, it's actually easier if we go ahead and split this apart and rewrite it strategically. So what we're allowed to do is we're allowed to take each term from the numerator and divide each one individually by that x to the fourth. All right, we've used this process a whole lot more if you get a common denominator first and then put all those terms together over that common denominator. But you can use it this direction as well. The next thing I'm going to do is go ahead and reduce each one of these individual fractions down. They each have x's in both numerator and denominator. So what we can do is basically think, where do we have more x's and how many more? So the 6 is going to remain up in the numerator. And then we have more x's by 1 up in the numerator. So we're going to have 1 extra x up there. So that first fraction reduces down to 6x. The next fraction, we have x to the fourth over x to the fourth. So that makes a 1. So we'll just be left with 6 in that case. And then finally, we have 3 is going to be up in the numerator. But we have more x's in the denominator, and we have 1 extra. So that'll be x to the first power still left in the denominator. Now, we want to take the derivative, but before we do so, let's strategically rewrite this last fraction. This last fraction, we can rewrite it by moving that x up to the numerator and using a negative exponent. So this can be 6x plus 6 minus 3, and then x to the negative first power for that new exponent. Why I want to do this instead of using the quotient rule is because I would rather just use the power rule whenever possible. So finally, taking the derivative, kind of one term at a time, let's walk through it. We have the 6x, so I can bring along the 6. That x is raised to the first power, so power rule says you bring the exponent down, and then you reduce the exponent by 1. So we have 1 minus 1 is going to give us 0 for our exponent. Next, we have a constant function. Derivatives of constant functions are always going to be 0. And finally, to wrap this one up, we have that minus 3x to the negative first. I'm going to bring along that constant, the minus 3, but now we want to use the power rule for the x to the negative first. So negative 1 comes down, and we want to reduce the exponent by 1. So remember, you take negative 1 minus 1 more makes negative 2. We can clean this up a little bit and give a slightly better final answer. If we do 6 times 1 is going to be 6. And it's still multiplied by that x squared, or sorry, x to the 0 power. But hopefully we recall anything raised to the 0 power is a 1. So the 6 is still multiplied by 1. I don't need to write that next to it. The plus 0 in the middle, we don't really need to bring that down. And then that last term, we have negative 3 times negative 1 is going to make positive 3. And then you could leave this with x to the negative second power, or you could rewrite it as 3 over x to the positive second power if you want to see a positive exponent when we get done. Usually it doesn't really matter if you leave it with a negative exponent or a positive exponent with the rewriting. All right, hope this helps out. Good luck. Keep working on these derivative rules and strategically rewriting these to make them easier.